Okay, guys, we're going to talk about something called an indirect proof. And it's just a different way of proving something. It's a little bit different, uh, but it's something that actually gets done quite a bit. And it's using a negation here. It's saying the opposite of something. And if you think about arguments, and sometimes, you take that you want to negate what the other person is saying and saying that can't be true. And so, because it can't be true, then my conclusion is therefore true. And a lot of court cases are like that. They want to prove that their client was not at the scene of the crime, or that this was not his fingerprints, or not his DNA, or whatever it is. And so, what we're going to work with here is a pretty formulaic thing, guys. Here, there are 4 steps. Step 2 is definitely going to be the one where we're going to do the most work here. Step 1, 3, and 4 are really almost always very, very similar. Step 2 is where things get a little bit different here. So, step 1 is we want to temporarily assume the negation, which is really just the opposite, okay, negation or opposite of the conclusion. And what we're going to do given and proves. So it's going to be the negation or the opposite of the prove. So as I look at my indirect proof, I'm going to start down here. Okay. The first step is, okay, we're going to temporarily assume. I'm going to write this out here, and it's going to be in paragraph form. Temporarily assume that angle 1, what would be the opposite of not congruent? Well, it would be congruent. So we're going to temporarily assume that angle 1 is congruent to angle 4. And guys, that's step 1. It's all you got to do. Okay, now step 2 is where we get into a little bit of work here, is we want to reason logically. Okay, reason logically. I'm going to tell you what we're going to do here. Okay, logically means we're going to use theorems. Theorem, yes. We're going to use definitions. Okay, we're going to use properties. We're going to use all those things that we did before. That's how we're going to reason logically. And what we want to do is we want to find a contradiction in the hypothesis. But for us, it's going to be the given. So what I want to do is I want to use that assumption here that angle 1 is congruent to angle 4. Okay, and I want to prove that that makes A and B parallel. I want it to contradict this given information. So what would we do here? Well, I think the first thing we would do here is say, hey, if, and I look at my picture here, I can say, hey, angle 4, I know is congruent to angle 2. Okay, so we're going to say angle 4 is congruent to angle 2 by, well, those are vertical angles here. You got that little X here. By vertical angles are congruent. Okay, and then what I can say is that angle 1 would be congruent to angle 2 by the transitive property. Okay, I'm going to abbreviate here a little bit. Okay, and you're saying, why am I doing this? Why am I getting angle 1 congruent to angle 2? Well, if I look at this, if I can say angle 1 and angle 2 are congruent, notice that those are corresponding angles. And if the corresponding angles are congruent, then we know the lines are parallel. So that's what we're going to say next. So so A is parallel to B because if the corresponding angles are congruent, then the lines are parallel. And notice now I have found my contradiction, guys. I have a contradiction here. I know I said A is parallel to B by using this information, negating the prove. And notice that this has contradicted the given that A is not parallel to B. That line through just means it's not parallel. So I'm done with step 2 now. I've found that contradiction. Now step 3 is, hey, I want to state then that my assumption that angle 1 must therefore be false. So I'm going to write something like this. This contradicts the given that A is not parallel to B. Oh boy, let's try that again. A is not parallel to B. So the assumption that angle 1 is congruent to angle 4 must be false. Okay, that's step 3. Okay, let's talk about this assumption being false. Okay, why is it false? Because we contradicted something in the given information. Okay, and then the last step is then, hey, I'm going to state then that my conclusion must be true, or in other words, what I want to prove is true. Okay, so we're going to say, therefore, angle 1 is not congruent to angle 4. That's it. And that's the last step is actually probably the easiest one, that we just say, hey, since that's false, then I know that this must be true because it's the opposite of that. Okay, let's take a look at another one here real quick. Okay, if we're given that angle A is greater than angle B, and we want to prove that CA, okay, this length here, C to A, is not equal to C to B. Okay, so first step is to take our proof statement and temporarily assume, okay, so we're going to temporarily assume that CA is equal to CB. And that's the first step here, guys. That's it. Okay, second step is we're going to use this information to disprove something in the given. Well, guys, if CA is greater than CB, then we would know angle A is congruent to angle B. Why is that? Well, because that's the isosceles triangle theorem, guys. So then A is congruent to B by the isosceles triangle theorem. And I'm going to abbreviate here a little bit. And that's fine. Well, that's step 2, because notice that I found that contradiction with the given. You can't be congruent and be greater than. So we're going to say, however, this contradicts the given information that angle A is greater than angle B. So CA equal to CB must be false. Okay, really, once again, guys, kind of formulaic. I'm stating my contradiction with the given and saying that that makes that assumption false. Okay, and the last step is then, therefore, since this has to be false, CA is equal to CB has to be false, therefore, CA does not equal CB. Okay, and that, guys, is an indirect proof. Okay, pretty formulaic. You can really get complicated here in the middle step, but the first, third, and fourth are pretty much always the same.